Have you ever pondered over the theory of evolution? Ever questioned its validity? It's a theory that has become so widespread, so universally accepted, that it's often treated as an indisputable fact. It's taught in schools, it's discussed in casual conversations, and it's referenced in pop culture. The theory of evolution has, for all intents and purposes, become a cornerstone of modern scientific understanding. But here's the thing about science: it's an ever-evolving field. It's a discipline that thrives on skepticism, on questioning, on constantly challenging what we think we know. Theories are not meant to be blindly accepted, they are meant to be scrutinized, debated, and dissected. They are meant to be put under the microscope, to be examined from every angle, to be tested and retested until we can be confident that they hold up under scrutiny. And that's exactly what we're going to do with the theory of evolution. We're not going to take it at face value. We're not going to accept it just because it's been widely accepted. We're going to question it. We're going to probe it. We're going to challenge it. Why? Because that's how science works. Because that's how we make progress. Because that's how we get closer to the truth. And in the end, that's what we're all after, isn't it? The truth. So join us as we embark on this journey of discovery. As we peel back the layers of the theory of evolution, as we delve into the evidence, as we explore the arguments, as we challenge the assumptions. This is not a journey for the faint of heart. This is a journey for the bold, for the brave, for those who are not afraid to question, to challenge, to seek the truth. We're not just uncovering minor imperfections, we're challenging the foundation of the theory of evolution itself. The theory of evolution, a scientific fact, or merely a well-accepted hypothesis? Let's dive into this question by first understanding the distinction between a scientific theory and a scientific fact. A scientific fact refers to an objective and verifiable observation. It's the basic unit of scientific knowledge, something that has been tested and confirmed so many times that we no longer question its validity. On the other hand, a scientific theory is a well-substantiated explanation of some aspect of the natural world. It's an interpretation, a model of the world that allows us to make sense of the facts. However, even the most solid of theories are always open to revision and falsification as new facts come to light. Now, let's turn our attention towards evolution. Evolution, as it stands, is considered a scientific theory. It's a model that seeks to explain the diversity and complexity of life on Earth, suggesting that all species have evolved over time from a common ancestor through a process of natural selection. But here's the catch. A theory, no matter how widely accepted, is not an absolute truth. It's a working model, a framework that helps us understand the world around us. It's only as good as the evidence that supports it and the predictions it allows us to make. When it comes to evolution, while there's a considerable body of evidence purported to underpin the theory, there are also significant gaps and inconsistencies. There are questions about the fossil record, the complexity of life, and the information in DNA that the theory of evolution struggles to answer satisfactorily. So, is evolution a proven fact? No, it's a theory, a powerful one, yes, but still a theory. It's an interpretation of the evidence, not the evidence itself. And like all theories, it's open to challenge, to revision, and even to being discarded if new facts come to light that it cannot explain. Thus, evolution remains an unproven hypothesis, a conjecture open to debate. Fossils, the supposed evidence for evolution, do they truly support the theory? Let's delve into the fascinating world of fossils. According to the theory of evolution, life forms have gradually evolved over billions of years, leaving behind a trail of fossils that supposedly chronicle this slow and steady journey. But wait a minute. Do the fossils really tell this tale? If Darwin's theory were accurate, we would expect to find countless intermediate fossils demonstrating the gradual evolution of one species into another. Yet the fossil record reveals something quite different. There are massive gaps, or what scientists call missing links, in this supposed evolutionary chain. These missing links are not minor hiccups, but significant chasms. For instance, the transition from invertebrates to fish, from fish to amphibians, and from reptiles to birds all lack clear, undisputed fossil evidence. Isn't it curious that these significant evolutionary leaps are missing from the fossil record? Even more intriguing is the case of the Cambrian Explosion, a period around 540 million years ago when a vast array of complex life forms appeared suddenly in the fossil record. with no clear evolutionary ancestors. This sudden burst of biodiversity is a stark contrast to the gradual evolution proposed by Darwin. Also, consider the concept of stasis, a term used to describe species that show little to no evolutionary change over millions of years. Many species appear suddenly in the fossil record, remain virtually unchanged for millions of years, and then disappear. If evolution were a universal law governing life on Earth, wouldn't we expect to see more evidence of change? In conclusion, the fossil record, rather than providing seamless evidence for gradual evolution, presents a patchwork of puzzling anomalies and significant gaps. The fossil record, therefore, presents a significant challenge to the theory of evolution. Can the complexity of life be accounted for by random mutations and natural selection? Immerse yourself in the intricacies of biology, the study of life itself. From the smallest microorganisms to the largest mammals, life presents an astounding array of complexity. Each organism, each cell, each molecule works in remarkable synchrony, following precise patterns and rules. Consider the human body, a marvel of biological engineering. Our brain, the most complex object in the known universe, contains approximately 100 billion neurons, each connected to thousands of others. This intricate network, each connection crucial, generates thoughts, memories, emotions, and drives our very consciousness. Consider our heart tirelessly pumping blood to every corner of the body, supplying oxygen and nutrients to keep us alive and well. The immune system, a microscopic army, defends us from external threats, remembering past foes and preparing for future battles. And consider the DNA, the blueprint of life. It's a microscopic ladder twisted into a double helix, carrying the instructions for building and maintaining an organism. A single mistake in this code can lead to disastrous consequences. Yet the code is replicated with astounding precision every time a cell divides. Such complexity, such precision, such harmony. Can it all be accounted for by random mutations and natural selection? The more we delve into the intricacies of life, the more we marvel at its complexity. And the more we marvel, the harder it becomes to attribute it all to randomness. It's like finding a fully functioning smartphone in the middle of a desert and attributing its existence to the random arrangement of sand particles. It's not only improbable, it's practically impossible. The complexity of life points towards a designer rather than random processes. It speaks of purpose, of intention, of intelligence. It speaks of something or someone beyond our comprehension. The Cambrian Explosion, a mystery evolutionists struggle to explain. Imagine for a moment a quiet, serene ocean floor, then in a geological blink of an eye, it's teeming with an astonishing variety of complex life forms. This is the Cambrian Explosion, a sudden burst of biodiversity that allegedly occurred 500 million years ago. The traditional theory of evolution proposes a slow, gradual development of species over eons of time. But the Cambrian Explosion, well, it tells a different story. You see, during this relatively short period, virtually all major animal groups, or phyla as we call them, appeared in the fossil record. And they didn't just appear in a simple form, oh no, they arrived fully formed, fully functional, and incredibly complex. Evolutionists have tried to explain this conundrum. Some suggest an increase in oxygen levels, others propose the evolution of predation, while a few cling to the idea of punctuated equilibrium, where evolution happens in rapid, isolated events. However, all of these theories struggle to account for the sheer speed and scale of the Cambrian Explosion. From a creationist perspective, the Cambrian Explosion makes perfect sense. If, as we believe, all life was created by an intelligent designer, then the sudden appearance of complex organisms is not only expected, it's predicted. You see, the Cambrian Explosion, it doesn't fit the slow, steady pace of Darwinian evolution, but it does fit comfortably within the timeline of a creationist framework where life is the product of purposeful design. In the end, the Cambrian Explosion exposes the limitations of the evolutionary theory. It's a glaring anomaly, a puzzle piece that just doesn't fit into the picture evolutionists are trying to assemble. The Cambrian Explosion remains an unsolved mystery for evolution, yet fits perfectly within a creationist framework. DNA, the blueprint of life. Can it originate from random processes? Let's delve deep into this. DNA, or deoxyribonucleic acid, is a complex molecule that carries the genetic instructions used in the growth, development, functioning, and reproduction of all known living organisms. It's an intricate system of information storage, comparable to a highly advanced computer program. But here's the conundrum. Where did this information come from? Evolutionary theory suggests that this information came about through a process of random mutation and natural selection. However, this assumption encounters a significant hurdle. The probability of even a simple protein molecule forming by chance is astronomically low. And DNA, well, it's not just one protein molecule, it's a meticulously organized sequence of billions of molecules. Moreover, information by its nature requires a sender and a receiver. It's a product of intelligence, not randomness. When you read a book, you don't assume that the words on the page appeared by chance, do you? You acknowledge an author, a source of the information. So why should the information in DNA be any different? This information also needs to be interpreted. DNA contains instructions to build proteins, but those instructions are useless without the cellular machinery to read and execute them. It's like having a manual in a language you don't understand. Without a translator, the manual is meaningless. So where does the translator come from? Evolutionary theory struggles to explain this. It's a classic chicken and egg problem. What came first, the DNA with its information or the cellular machinery to interpret it? Both are needed for life and both need each other. It's a system that points towards design, not chance. To conclude, the information in DNA is vast and complex, and its origin remains a significant problem for the theory of evolution. This complexity, this information, it doesn't point towards randomness, it doesn't point towards chance. The information in DNA points towards an intelligent source, a creator. Creationism, often dismissed as unscientific, but is it truly so? Let's delve into the scientific accuracy of creationism. When we consider the intricacies of life, from the smallest microorganism to the vast human brain, the random mutations and natural selection proposed by evolution seem rather insufficient. Creationism, on the other hand, posits an intelligent designer behind these complexities, a perspective that aligns with the evidence we see in the natural world. Let's examine the Cambrian Explosion, a period in Earth's history where we observe a sudden burst of diverse life forms in the fossil record. This event poses a challenge to evolution, which predicts a slow, gradual development of life. However, creationism can explain this phenomenon, suggesting an initial creation event where numerous life forms were created simultaneously. Another area where creationism shines is in the realm of genetics. DNA, the blueprint of life, is packed with complex, specified information. Evolutionary mechanisms struggle to account for the origin of such information. It's rather like expecting a tornado sweeping through a junkyard to assemble a fully functioning Boeing 747. In contrast, creationism postulates an intelligent source for this information, providing a more plausible explanation. Furthermore, creationism aligns with the second law of thermodynamics, which states that systems tend towards disorder, not increased complexity. This is quite the opposite of what evolution proposes, yet it agrees with the creationist view that we live in a world affected by decay since its initial perfect creation. Creationism also provides an explanation for the existence of irreducibly complex systems in biology. These are systems that require all parts to be present simultaneously to function, something that gradual evolution struggles to explain, but fits perfectly with a creation event. In conclusion, creationism, far from being unscientific, presents a compelling explanation for the origin and complexity of life. It offers a framework that aligns with the evidence we observe in the natural world and provides satisfying answers to questions that evolution finds challenging to explain. Creationism, therefore, deserves our serious consideration as we seek to understand our origins and the world around us. The debate between evolution and creation, a necessary dialogue in our quest for truth. It is a discourse that has traversed centuries, engaging minds of all walks of life. Scientists, philosophers, theologians, all grappling with the same enigma, the origin of human life. This debate is not just an intellectual exercise, it is the very bedrock of our understanding of humanity. It shapes our perception of who we are, where we come from, and perhaps where we are heading. It is therefore paramount that we approach this dialogue with an open mind, ready to examine and scrutinize every theory, every claim, every piece of evidence. The scientific community thrives on open dialogue and debate. It is through this rigorous exchange of ideas that we expand our understanding of the world. Evolution and creationism are not exclusionary concepts. They are theories, each proposing a unique perspective on the origin of life. Evolution, a theory that posits life as a gradual process of change and adaptation over millions of years. It presents a narrative of life that is ever-changing, adaptable, and resilient. On the other hand, creationism posits a divine creator as the architect of life. It presents a narrative of life that is intentional, purposeful, and intricately designed. Both theories have their merits and their shortcomings. Both have been subjected to intense scrutiny, rigorous debate, and continual refinement. And that's the beauty of science. It is not a static body of knowledge, but a dynamic process of discovery. It is a journey, not a destination. The evolution-creation debate is not about winning or losing. It is about seeking the truth, understanding our world, and expanding our knowledge. Only one of the theories explains our history. In our pursuit of truth, we must question, we must debate, and we must remain open to all possibilities. Despite widespread acceptance by scientists, the theory of evolution remains controversial due to numerous challenges and unanswered questions. We began by posing the question of human evolution, a concept that, though widely taught and accepted, is still fundamentally a theory. We then delved into the fossil record, a supposed testament to evolution, yet one riddled with gaps and inconsistencies that challenge the linear narrative of species transformation. Next, we examined the astonishing complexity of life, from the tiniest cell to the largest mammal. The immense intricacy of biological systems and processes we found defies the simplistic explanations offered by evolution. We then shed light on the Cambrian Explosion, an event that saw a sudden burst of diverse life forms, contradicting the gradual progression that evolution proposes. We also discussed the information encoded in DNA, a language so complex and precise that attributing it to mere chance seems implausible. This complexity, we suggested, points towards intelligent design rather than random evolution. And let's not forget our exploration of creationism, a perspective often dismissed, yet one that aligns remarkably well with scientific evidence. We've shown that the creation-evolution debate is not a battle between faith and reason, but rather two different interpretations of the same evidence. In conclusion, while evolution is a widely accepted theory, it is just that, a theory. It's a hypothesis that attempts to explain the diversity and complexity of life, yet it struggles with numerous unresolved issues and unanswered questions. It's a theory that, despite its popularity, is not a proven fact. In the grand scheme of understanding the origins and progression of life, evolution presents one perspective, but it is not the only one. Other perspectives, like creationism, provide compelling alternatives that align more closely with the evidence at hand. The theory of evolution, while widely accepted, remains a theory, an enigma, yet to be fully unveiled. In our quest for truth, we must remain open to all possibilities. As we traverse the winding pathways of knowledge, it's essential to remember that the destination isn't always visible from the starting point. The pursuit of truth is a journey, often filled with twists and turns, dead ends, and unexpected revelations. In the realm of human evolution, the same principle applies. We've embarked on a journey, perhaps one of the most profound and personal ones, to uncover the origins of our species. In this exploration, it's imperative to remain open-minded. Just as a scientist doesn't let personal bias cloud their research, we shouldn't let preconceived notions obstruct our pursuit of truth. It's easy to accept theories and ideas that align with our beliefs, but true wisdom lies in questioning, in embracing the unknown and the uncertain. It's only through this relentless inquiry that we can hope to unravel the enigma of human evolution. Science in its purest form is a process of discovery. It's not about proving one theory right or another wrong. It's about understanding the world around us, about unraveling the mysteries of nature and our place within it. The theories of evolution and creationism are part of this broader quest for understanding. They represent different perspectives, different ways of interpreting the evidence we have about our past. In this quest for truth, it's important to remember that it's okay to question. To question is to seek understanding, to challenge the status quo, to push the boundaries of what we know. It's through questioning that we learn, grow, and evolve. It's through questioning that we inch closer to the truth. So, as we close this exploration of human evolution, let's not see it as an end, but rather as a beginning, a starting point for further inquiry, for deeper understanding, for more profound discoveries. Let's continue to question, to research, to seek. Let's continue to challenge our beliefs, to push our boundaries, to expand our horizons. Remember, truth is not afraid of questions. Let's keep questioning, keep exploring, and keep seeking the truth about our